Good morning, everyone. Can you hear me okay? Okay. Alrighty. So I have a long name and an even longer title on my slide here. So I'm going to have to talk really, really quickly to make sure we get through a lot of the things that I wanted us to talk a little bit about. And I thought I'd just sort of cut to the chase and tell you a little bit about who I am and my experiences to give you a sense of why I do the things that I actually do. So I just got promoted to full professor at the University of Vermont. So thank you. Yeah, that was fun. Um, so I actually started having to say that first and foremost because being a state climatologist, people think that I'm a state employee. And so I've started in the last few years actually telling people that I'm a faculty member first and foremost, which means I take care of students first and foremost. And the state climate piece is a service piece which sort of supports the other things that I do. And so because I'm the state climatologist, a lot of times I spend a lot of time listening to people and listening to what they actually need as opposed to what they actually want. And that has sort of trickled into the education component that I've sort of picked up over the last 6 or 8 years or so. Some of the institutions that I've been part of include the American Association of State Climatologists. I also serve with Jim Curl actually on the NOAA Science Advisory Board Climate Working Group. And so those have sort of given me slightly different perspectives that I, like I said, try and bring together from a sort of local to a more national perspective. So some of the people that I actually spend a lot of time talking to include not only K through 20 students, but also I work a lot with the media, and that has taught me a different way of how do you choose words carefully, so that when I say things like I'm tailoring my message to my audience, that raises flags to a journalist. What I'm actually trying to say is if I'm talking to students, I'll use different words than if I'm talking to somebody who's in the agricultural field. So even the word tailoring has different implications. So on the slide here, I'm not going to read it out to you. These are some of the folks that I've sort of interacted with over the last 17 years or so, and they've sort of shaped my thinking as a professional and some of the programs that I've run. So thank you, Diane, for bringing up that sort of need to decode the way in which we speak as scientists, as geoscientists. And a lot of this sort of comes out of teaching undergraduate students and listening to what they say and listening to where they get their perceptions from and how these have sort of stuck with them a lot. So one of the things that got me involved in geoscience education is the whole notion of Coriolis force. Okay, something as basic as that. And students will come in year after year and they'll say, you know, the Coriolis force causes your toilets to flush one way in the northern hemisphere and the other way in the southern hemisphere. And I say, who told you that? And they always say, a grade 8 teacher. So that's one of the reasons why I founded one of the programs I'll tell you about in a little bit. And it also got me thinking that every time I give a presentation, not just the words that are on the slide, but also the figures that are on the slide are critically important because figures are so subliminal in terms of the message that they're conveying. And I absolutely love this one here from Comet because it shows you the greenhouse effect in terms of it not being a trapping event, but a sort of getting down to the process level. You know, the emission and absorption and all of those words that sometimes we avoid, and using metaphors that then get stuck as children come all the way up through it. By the time they get to my level, then some of these misconceptions are a little bit on the pervasive side. So when you would think about that, critically important for us to talk a little bit about. So from all of those folks, there are a couple of lessons that I've learned. I've kind of given these to you on here. And one of the big ones that I'll kind of stress is where you are in terms of your life experience and how does that kind of color and shape some of the processes that you bring to the table. The other pieces on here, things like where in the curriculum do we try and make a difference in terms of our intervention, the types of learning styles that we have in the room itself, also critically important. I'll talk a little bit about that in a sec. And educators and the sort of role that we can play in terms of helping to shape the conversation itself. So there are 2 programs that I have funded through the Geoscience Education division at the NSF. I'll talk a little bit about first. This one's called the ClimeNet, and it stands for Diversity Climate Network. And as we know, it's all about the acronym. So I sat there and I tried to come with something that was hip and cool and whatever. And so I said to the students that I work with, I'll tell you a little bit about them in a sec, does the climate resonate with you? Does it sound cool? And they go, yeah, right, whatever. Right? So I kind of probably failed that test, but it got in all of the pieces that I wanted to bring to the table in terms of climate as a focus, climate with a capital C, the diversity of the audiences that we're looking at here, and the networking piece in here. So what is the climate, who's involved, and what are we trying to do? So we're trying to target students, primarily students of color, students that are women students, and trying to get them to think about climatology as a valid and employable type of career option. And when I say climatology, I used to actually say climate sciences, but I broadened it back out to climatology because it includes the policy dimensions as well as the process dimensions. And so the three audiences that we look at are high school students. I work with students both in Vermont as well as students in the Manhattan region. We also work with community college students out in LA. And then the final piece are the graduate students at both the University of Georgia as well as the at UCLA itself. So we've got three different levels, and we're trying to do the sort of pipeline or watershed type of approach to getting the students both in, sort of doing a lot of the peer mentoring. So this is the climate website on here, and I'll just introduce you to some of my colleagues. Marshall Shepard is at the University of Georgia, as is Tom Moat, and Marilyn Raphael is at UCLA, and you may recognize Warren Washington. He'll be talking to us tomorrow. He's actually flying back in today. So when we try and get some of the word out in terms of what are we trying to do with this particular program, a lot of it is sort of starting small and building larger. And so we've been able to support two graduate students, one of whom is down here, Jason Ward. He started off as an undergraduate student at UCLA in the geography department. And when I first met Jason, he was kind of shy and, you know, not quite sure what was going on with this whole undergrad-grad thing. Now Jason is finishing up his master's and continuing on to his Ph.D. And the self-confidence that has sort of come through in terms of that ability to choose your own project and to have mentors that are there to say, yes, you can do it, and you should do it, that type of thing. To the extent that here he is giving a lecture at my class, my climatology class, last year, and talking about his work on sea ice in the Antarctic, and relating with my students in ways that I wasn't able to draw them out. Is that sort of peer mentoring that we've been hearing a lot about across in here. And the other student is Marcus Williams. He is about to finish his PhD at University of Georgia, and his work actually takes him to Liberia to work with the Liberian government on planning issues for climate change topics. Marshall is the one who's put together all of the Facebook stuff, and Marshall is the immediate past president of the American Meteorological Society. He's also published, I forgot to mention this on the previous slide, a lot of work in sort of popular literature as well. So he's got an Ebony article that talks a little bit about the stuff that we've been doing in the climate. So I probably would not be standing here today if it were not for Warren Washington. And Warren invited me here to spend the summer at NCAR back in 1990. So it's always a joy to come back in the Mesa lab and spend some time here. And I like to use this particular picture to validate students in terms of the question, who do you look up to? And they usually tell me their mom or their dad or a particular sports figure. And then I say, why? And then it comes out, it's either a values-based system or it's somebody who's made a difference or has overcome a lot of challenges. And that's what they sort of hold on to. And so, you know, validate that piece. And then I say, so this is who we look up to. And they go, President Obama. And I go, him too. And then I say that we also look up to Warren Washington and the fact that he's been a pioneer in terms of the atmospheric sciences and diversity in the atmospheric sciences for the last 40 years or so. And it was actually my great privilege to give him the honorary geographer award about 2 months ago. So it's sort of come full circle, which of course has a lot of meaning for us. So some of the lessons that come out of this particular program include the fact that climate sciences, geosciences are not even on the radar for a lot of the high school students that I work with. And, I started off with thinking, I can actually go into the high schools, give them a bunch of materials, they come out and they suddenly want to be climatologists. No. Okay? So we had to kind of back off on that and actually kind of meet them where they are and say, I understand that you don't want to be a climatologist because you have no idea what climatologists do, or geoscientists, or whatever, right? So recognizing that some of this stuff is not even an option for them is sort of like below ground zero, all right, in terms of what we do. A lot of the other pieces that I saw, because this program went from 2009, we just finished the pilot last year, was when President Obama became president, we saw a subtle shift in the way that the students were thinking about the sort of yes we can. And that's something intangible you can't exactly quantify and measure, but it's one of those pieces that you sort of take it and work with it in terms of how do you capitalize on whatever you actually get handed. So that's a decline level. My second program is called SWAC. And yeah, I thought that was kind of cute. So what does SWAC stand for? And it is satellites, weather, and climate. And this one's a little bit different because this one is actually focusing on K-12 teachers. And what we're trying to do here is to support teachers wherever they are in the curriculum, grade-wise, as well as content level-wise, in such a way that they can effect the type of change that they're trying to effect in their classroom because they're now confident in the material that they have, okay? So how do we do some of this and what does it actually look like? Oh, by the way, see these across here? These are called cricket SWAC. And they are little instruments that are designed to take temperature, pressure, and humidity, both on the ground as well as during balloon launches. And Mike Fortney, who is the one who designed them, has them both chirp like a cricket, depending on what the temperature is. It goes beep, 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 right? That sort of thing. But they also flash lights. And so what you're doing is you're allowing differentiated learning to take place in the classroom, both for visual learners as well as for auditory learners. And what we're trying to do with this is it's very challenging to have all grade levels present at the same time because of different background preparations. And so what we try to do is to make this sort of inquiry-based, problem-based, project-based, place-based type of approach so that the questions that the teachers develop are authentic for the students actually pursuing them. So for example, they'll throw out a topic like ozone, which is a pretty broad topic, and you have to be pretty comfortable in the responses that the students will give you. So what do you mean about ozone? Well, that's what you're going to tell me. And they build that and create a project around that in a way that makes sense for their particular curriculum, whether it's earth science or chemistry. So we've heard earlier today about tapping into students, especially very, very young students. And when we do that, there's a body of knowledge that I'll talk about in a sec called nature science, which gets at how do you actually target students before they become a little bit more jaded as they get a little bit older. And so anything that's sort of hands-on is really great. Have you ever seen these ultraviolet frisbees? Wicked cool. Google them for $10 a pop. I'm not selling them. I'm just telling you about them. Here's that balloon launch that we're talking a little bit about across it in here. And here are some kids at the balloon launch. They're 4 years old, and numbers are coming down. They're writing them down, the beeps, right? And they're like, give me data, give me data. They have no idea what data are, but that's okay. The 7-year-old who's writing the data down, after about 10 minutes, I said to him, what do your numbers look like? And he says, well, the balloon's going up and the temperature's going down. And I said, bingo. That's the definition of a lapse rate. Okay, I didn't have to confuse you as you were saying, very good lapse rate, right? But he just told me what a lapse rate was by looking at the numbers and following what was going on process-wise. So when we're talking about starting young, it's not just the nature of science literature that tells us about that, but it's also when do misconceptions start. And so what I'm trying to do is by helping the teachers be flexible enough in their content so that when they teach, the correct processes are imparted, then that sort of cuts down on trying to prevent misconceptions later on. Because another body of work in the cognitive sciences shows us the more you try to get something out, the deeper it gets embedded. And so what you're trying to do is to not get it wrong to start with. Okay, so that's another reason as to what we're trying to do in here. And the last bit is, I also have gone to the point that I ask my students, is this your first time that you're exposed to a lot of this stuff? And they say yes, which is actually a little bit sad, because a lot of these concepts have now become so everyday that it makes more sense to get some of this basic understanding across the board. So what have we learned from SWAC? Well, a couple things that we've learned is that I no longer stand at the front and do this sort of imparting thing. It's more a collaborative type of approach where the teachers themselves are actually doing a lot of the workshop. So that's what I mean by this teacher-learner component across here. And not only are they facilitating the workshops, but they're also doing peer mentoring in terms of a high school teacher might assist an elementary teacher with some of the concepts that they want to get across in their particular class. And because it's, you know, some of the stuff that we do as geoscientists is so pervasive across the entire society, it can be brought into chemistry, physics, earth science, history, social science, environments, and so that allows us to try and encourage a more whole school approach and embed it across different core areas as well. So when I think about what are some of the things that sort of characterize us as geoscientists and probably set us apart a little bit from some of the other scientists, is that there's some things that are different in terms of thinking spatially and thinking about feedback loops, but also thinking about things in 3 dimensions, okay? I'll go back to the ozone example. You know, tropospheric ozone versus stratospheric ozone, and the ability to keep those separate. When I explain this in class, everybody does like this, right? Because it all makes perfect sense. But when I ask the question on the final exam, and I know it's being filmed, so there goes that final question. When I ask the final question, distinguish between tropospheric ozone and stratospheric ozone, what's the difference between the two? I kid you not, I got. Stratospheric ozone is made up of greenhouse gases like carbon dioxide and methane. So now we have a complete mixing of not only the levels in the atmosphere, but also the chemical composition and processes, which speaks to how do we try and bring in some of the things that you were talking about, Diane, in terms of visualization, okay? And so I thought I would kind of bring all of this to a close by putting all of these experiences into 3 different categories. So talk a little bit about the students, talk a little bit about us as educators, and then some more general stuff. So in terms of students, we've heard this a lot. We'll probably continue to hear it throughout the workshop. The need for having role models and the need for having mentoring at all various levels. One of the things that I found critically important is also the need for cultural sensitivity. And when I think about this, I'm thinking about this from the context of where I work in Vermont. Vermont is home to a number of refugee new Americans. And in working with them, there are some interesting dynamics that come out when you have 28 different languages being spoken in the same school, for example. And the way that this then translates into how do the male students adjust versus how do female students adjust. And very interesting dynamic that male students tend to try and be assimilated more, and female students tend to be together in an isolated group. And how does that then affect the learning that's actually taking place in the classroom itself? So these are some of the things that we need to sort of think a little bit about as we step on through with our students. The other thing that we need to think a little about comes back to, again, the choice of a career option, and both from an awareness perspective, if you don't know a particular career exists, you're probably less likely to choose it, but also from a content perspective in terms of what they're trying to do with that particular knowledge itself. And I'm a big believer in K through grade, so our learning does not stop when we graduate. And I've learned that because I give so many talks to retired communities, and the amount of knowledge that is in that room is one of the greatest joys in my life to be a scientist, because I always learn so much in dealing with everybody across the entire curriculum. And so this is sort of reflected in here, and it also speaks to what is important from a curricular perspective, because here is the breakdown of a question that says, where's your information coming from? And I ask the same question, phrased the same way, among students and among staff members. Okay? It's a little bit dated now, but I'm sure some of these figures will probably still the same. So this huge yellow piece in here is a lot of my information is coming through class environment. And you notice that that is completely missing from the staff, who may range anywhere from early 30s all the way up to the 60s. And so when you think about the information content and how that is transmitted and then processed, it becomes critically important in the various venues that are out there. So those are students. What about us as educators? Well, this one is nothing new, that the need for, teacher professional development in a way that supports their curriculum. And like I said, it's not new, because one of the workshops that's almost 10 years old now actually identified this as a critical need for geoscience educators, and is still of ongoing importance in terms of making sure that our teachers are well prepared for not just our current challenges, but moving forward as well. So from a content perspective, critically important, but also from a visualization perspective. And I've learned that even in my own experience, you can only do teachable moments and sort of ability to go off on a tangent and be flexible if you're comfortable enough in the content that you're working with. And so that's what I'm trying to get at across here, so that when we think about the ways that we can actually try and foster this, a lot of it becomes more of an integrated approach and multi-level as well. So the final thing I'm going to throw out sort of comes to some of the things that I've already mentioned in here, including things like meeting people where they are, learning from different disciplines, including the cognitive sciences. But this is also critically important, our cultural references. I grew up in Trinidad in the Caribbean. I did most of my work in Canada. And so my cultural references are completely different than the students that I work with. And I needed to understand, appreciate that, and grow into that, and embrace that, so that when I do speak, it's not from a position of, oh, I have no idea what you're talking about, but let's see how we can actually get our cultural perspectives together in a way that makes sense. And you can only arrive at that by stepping through the process. You know how you always say you grow in 5-year increments? You look back and say, you know, I'm not in that place that I was 5 years ago or 10 years ago. So this is a process that goes on, and it comes from knowing yourself and knowing your strengths and working to those strengths. And then the final thing is, the point of all of this conference is to call a spade a spade. So I'm calling a spade a spade. Thank you.